Hello, I'm Daniel, and I'm going to explain a little bit what is WGET2. Um, well, first of all, we're going to talk a bit about WGET. I guess most of you know WGET. As you can see, it's a command line program, first released in 1996. That fetch fields from both HTTP and FTP protocols and with the security lawyer. It's not interactive, which makes it ideal for use on shell scripts, supports recursive downloading of a full website from a server. It continues broken downloads, which it was the maybe one of the first downloaders applications that supported that when the standard HTTP 1.1 was out and the ranch header was added there. And it's so stable that most people think it has no developers. Well, you can see there, I don't know if, well, it's a picture of WGET I got from somewhere in the internet. Well, you know WGET. So the question here is, why do we need to write an entirely new WGET? One of the reasons is that we want to support newer web technologies like HTTP2, which I will explain a bit later. We have new features that were almost impossible to implement due to the design decisions that were taken during WGET development. We have to have in mind that WGET was developed in the 90s. So the design and the approach of the program is very different, or was very different, than the one we have now. The great problem that WGET design has is the single-threaded design. So, well, it uses blocking sockets, static and global variables, and it has non-regenerant code. That's a great problem when you try to implement something like HTTP2, which works with parallel connections and that kind of stuff. Also, we wanted to avoid confusing switches because there were some decisions on WGET development which make some switches work in a way that now we don't think it's a good way. So we wanted to change that behavior now. Another example of features that were almost impossible to implement is a plugin framework we have on WGET2, which we will talk about it later. Well, we're going to see a brief of the history of WGET2. It was started as a library on 2013 by Tim, who is sit there. So, and imget was just an example implementation of a command line example of the API of libmget. Later, a year later, libmget was split, a part of it, into libs, which is now another library, which is also maintained currently by Tim. We are using it, that library, and also Carl is using it too. 4 years ago, mget was renamed to WGET2 and brought into the GNU project. A year later, we started to use GNU-lib, which ensures compatibility with great list of different platforms and operating systems. Now it supports, of course, GNU Linux, Solaris, macOS, BSD, also Windows with the Unix environment for Windows, which is there, and we even got it compiled and work on Haiku just for fun. Like 2 days ago, we got a full continuous integration and fast testing, which is very good to find bugs on the program. We are using GitLab continuous integration. A year ago, the first alphas were released, and like 5 days ago, we released the first beta version of WGET2. And also, we have to mention that in the last 3 years, we have 5 students on GSOC working on the WGET as part of the GNU project, which has implemented some different features we need, like the plugin framework, and we'll go through that later. Well, now we're going to talk about new features that WGET2 has and not WGET. Well, it's built around libwget. If you have been here in the morning on Teams Talk, you have already seen libwget. It's almost fully backwards compatible with WGET switches. We have still some that hasn't been ported yet. We are open to contributions in that, well, in any way. And also we have changed the behavior of just a very little switches, which works a bit different. Well, as I said, we use the continuous integration of GitLab because the project is, we're not doing it on Savannah. We are working on it on GitLab. There is a repository, so if you have a GitLab account, you can contribute or open issues or whatever. We have also, well, we use address and undefined behavior and memory sanitizers, which help us find some bugs. We also use Valgrind for memory leaks and all that. Also, we have a fast testing via the OS fast project, which is also very helpful. The test suite is written entirely in C with no scripting, or it's full written on C. And this is a difference with the WGET1 because there the test suite was written in Perl, and now it's all C.
We need an L file.
Huh?
Well,
maybe it's not.
No, L file is really, and that will work in memory.
Yes, it is.
And yeah, of course, my luck.
Because we have a lot of fancy features through libmicro HTTP and work together with them, implementing new features for them or with them together.
Yeah.
So we also get projects and keeping together here. And keeping in one language for the whole project was the goal after the experience with WGET1. Because it's really annoying. You need to know Perl in all its details and all its versions. You need to know Python. Yeah, and you have to be an expert in C. So there was more or less nobody who was able to handle all three of this in perfection. So now we have just one thing. Okay, sorry I interrupted.
Well, WGET is built with GNU TLS for HTTPS stuff, security stuff, and encryption. But since a little time, we can also it can also be built with Wolf is L and Open is L. This last one is the one that it's supported by the WGET1, and the support for WGET2 is not fully ready now, but it's going to be soon. Well, it uses not blocking sockets, which this is a different from WGET1, which help us to enhance performance. As I said, it has HTTP2 support. We have multi-threaded downloading. This is also a huge difference with WGET1. There is a switch, so you can set how many threads as maximum do you want. Default is 5, which works nice. We have also HTTP compression of the headers. And, in all those formats there, some of them need optional dependencies to work. Some others, like gzip, don't need optional dependencies. We have also TCP fast open, which allows us to start downloading faster from server, because data starts to come from the server during the three steps handshake, so it's a bit faster. We have also TLS session resumption and false start. Also, we respect the XDG base directory specification, which is good. It has also metalink support, which helps you with some other information that is not directly on files. And, we have some more. I also said that we use libs to test, the public services from the public services list. We use the HSTS. This is like when you connect, when you establish the first time an HTTPS connection on a server, that server, that domain name, it's added to a list. So the next time you try to connect to that server, WGET2 already knows that that server supports HTTPS, so it will not allow the connection to fall back to HTTP, which is security. It's a security thing. We also support HPKP. That's now that's a mechanism that sets some pines that you can use when you connect to the server. So you know that you are connecting to the right server. That's thing in the case that someone compromised an SSL third issuer. So even if the server the attacker is redirecting you has a good SSL certificate, you can know that the connection is not to the right server. This has many problems and disadvantages, and that's why Google has deprecated it since Chrome 67. We have it, we still support it, and we think we have plans for supporting it for some time. Now there is another one called Expect CT, which we will probably implement in the future. Okay, we have also the enforced perfect forward secrecy mode.
You have a first client, apart from the big browsers that were using this at all. And now it's standard, everyone.
Yeah, this helps so you don't know if someone, this is from the server. The server has to support it. So if service support it, it's a technology that lets you be sure that if someone, the private keys of the server, it's a private public key system, are compromised, all the encrypted data from before is not going to be compromised. That's what it is. We also have OCSP, which is a protocol that lets you check if ESSL certificate is revoked or not when you connect to a server. This is enabled by default on WGET2, but you, of course, you can disable it. So it has no much problem. Well, now, when you run recursive mode, WGET, the original one, used to parse, HTML to find some links, and that's recursive mode. Here we have the same in WGET2, but it's also, we also scan ATOM and RECs, and sitemap fields for information or links or whatever we need. It also supports IceCat and SourceCat streaming support if you want to download some streaming.
For people who like to do streaming with title information, so you can just, we have an example, few lines of C code that does print out the title information if you want to listen to music on your console. And that's how you
Okay. We also have more than 40 new switches that are present on original WGET for a bunch of things. And the only thing that WGET, the only major thing that WGET has and WGET2 doesn't has is FTP support. We have no plans now to implement FTP, and as WGET2 is now a different package than WGET, if you need FTP, you can use still WGET1, so it's not a great deal. Here we have some graphics we made to show that WGET has an improved performance over WGET1 and also curl. Well, as you can see, we have the wall time, which is the execution time.
Sorry, I can't read the writing. Can you briefly explain what the axes are?
Yeah.
You make bigger.
Okay.
Number of URLs along the bottom, wall block up the vertical axis.
Okay.
Here we have the wall time, which is the time of execution of WGET2 while we make this graphic. And here we have the number of URLs which were passed to WGET, WGET2, and curl. So, as we can see, of course, while the number of URLs grows, the wall time also grows. But thanks to the multi-threading support in WGET2, this, well, it's not a curve, but this increasing line, it's best. Yeah, by default is 5 threads. WGET2.
5 threads, that means if you double just one file or 5 doesn't really matter because they are downloaded in parallel.
Yeah.
And from 5 to 6, the increase in time is of course because you have to wait.
Yeah.
Because you have a queue of 10 and just 5 workers that work on them.
But you could set the maximum number of threads to 10, and you will get the line like this. The thing is that we are running, these are the, I haven't mentioned, the last versions, I mean, from the master Git, branch on Git, from the 3 projects, and they are running with default settings. We are not touching anything there, so maybe there is better options for curl or WGET1 to work, but this is with the 3 with default behavior. Yeah. And that is HTTP 1.1. We have this is HTTP 2. Which WGET1 doesn't support, so WGET1 is still with 1.1. Oh, well. Carl has HTTP2. So we can see that it works much better. There is increasing on the performance using the version 2 of the protocol instead of 1.1. And curl and WGET1 are like.
What you can see here is that the great curl tool has HTTP2 enabled, but is not able to squeeze the performance out of it. While WGET2 is really performant together with HTTP2. This is what you can see here. Curl doesn't really make use of it.
Yeah.
It's a huge difference. If you download complete websites, as you can see, it's WGET2 is so much faster than existing tools.
Well, as I said, most of the improved performance of WGET2 is due to the fact that we have multi-threading. But this is, well, you can see it there. Is the same like the other graph, the same arguments, but we are only running 1 thread. And still, as you can see, WGET is with a better performance than curl and also WGET1. And this is due to HTTP header compression and that kind of.
So defaults that are like TCP fast open is,
Yeah.
for example, disabled by default on curl. WGET1 doesn't support it at all. And yeah, we have it on by default as well as here as false start, so we see some improvement.
Yeah.
One thing I would like to mention here is, despite the fact that the graphs look really smooth, they haven't been smoothened or tampered with. It's just like that. Statistically significant graphs. Like each of these points were run for over 100 times to collect the mean.
Yeah.
You could have probably started error bars. They actually do have error bars. It's just you can't see them because
Okay, good.
so they actually have error bars for 95% confidence intervals.
Okay, great. Yeah, error bars, yes.
I wanted to mention that.
Well, this is back to HTTP1 0.1, but as you may see, the wall time is highly increased. You can see that. Here we are like 300, and here we are 800. So the graphics you saw first were made by Darcy on a server, on a data center, and all that. I made this one with the connection, the internet connection I have on a rural part of Spain. So it's like the worst connection you are going to see. The thing here is that with bad connections, WGET1 used to be, well, it is a really faster downloader. It really gets the best from the connection. You can see here, this is also because of multi-threading. Even if you have a connection nowadays, still WGET2 it's faster than WGET1. And well, currently is like I don't know, somewhere. So it's still there. That's what I want to show. Oh, GSOC. I said earlier that we have 5 GSOC students. These are the GSOC projects that we have these last 3 years. Well, yeah, well, the test framework, as Tim says, work with this lib, which is from the GNU project, which just lets you start a web server, a small web server, on your system while you run the test, and put there some configurations and all you need. However, I'm going to talk a bit about these 2 ones, because they're like the bigger ones, but this is from last summer, so I haven't mentioned earlier. The test suite also supports HTTP2 for the test. We have the plugin framework. The truth is that we have, this is from 2 years ago, we have no plugins yet, but we are going to make some, I guess. So it has some features, the plugin framework itself. It has command line option for forwarding, so if you, first of all, you have switches to list plugins, to load plugins, and that. It allows you to, as well as you give some arguments to WGET2, you can also give them to the plugins you are running. It's like this format. You have all the information is on the Git repo. We have a markdown file with which is like it's a user manual. So you have there a lot of information about all this if you want more than I'm going to explain here. It has API. We have API for intercepting URLs, which means that before any, this is especially for recursive mode. So you can have a plugin, and before, if it's loaded and it's running, and before WGET adds a new URL to the queue to be downloaded, plugin has the option to reject or upset that URL, and that's the highest precedence. So if you have some other options to accept or reject fields, like you can filter MIME types, or you can use regular expressions, or whatever. But if the plugin said yes, then the field is downloaded. If it said no, then the field is not downloaded. It's easy. This is another API. It just lets you to, when you download the field, the plugin framework is able to load it and parse it or whatever you want to do. So if, well, as I said, we already parse HTML, CSS, ATOM, blah, blah, blah. But you still check the field and add some other URLs to the queue or whatever you want to do.
For example, if you download PDF files and you know what you're doing, you can add a plugin to parse PDF for your URLs and give them back to the WGET engine, for example. This is an example how you can extend the functionality of WGET.
Yeah. And the last, we have, well, I have already mentioned these three protocols and mechanisms. WGET has his own databases on the system, but with plugins are able, through this API, to load some information for this one or this one or this one from any source you want or whatever. So you can add some settings for that using that API. Well, this is an statistic framework which has these features. They are statistics about the time. Well, of course, host, IP, port. You need to know what you have been downloading. You have all kinds of information of all this stuff. I mean, it's there. You can read. You can choose like two output formats because one is not really a format. You can choose human readable, which is just like good to see. You can easily see it and find whatever you want. But if you need that format, you can get it also. It's just we have switches for setting up all this. So you can. I have some examples here which are, but you don't see anything. No. I don't know.
Okay. Just go one back. Maybe I would like to say something. What's, for example, interesting is the size statistics. You can, for example, recursively download your own website and write every page get a statistics entry, so you know how long in milliseconds is the time downloaded. Sometimes the servers are busy with one page, and due to some database misconfiguration or something, you can see immediately if links go into nothing. So for you can also have the information, the CSV format, to pass it into JSON and a tree. So you can build a graphical tree, for example, with graphics, or we have a small tool that is called CSV to tree. That's the level on the console. This, well, maybe for one or the other, it's pretty interesting for website analyzing.
That's the. These are yeah, site statistic. I don't know if you see this one or. Well, I haven't mentioned you as well as you can choose the format. You can also say if you want to WGET to set the output on a file or through the screen if you are like seeing it on that moment, or maybe you need the data for something. is just redirect for standard output. Oh, thank you. Now?
That's right. Yeah, that's better.
Well, you can see there. You have all information.
Some statistics, the slides will be available, and you can always run
Yeah.
WGET2 to look at it. It's simple numbers.
Okay. Now we're going to talk about future enhancements we are planning to make on WGET2, or we would like to make. Well, we would like to make a major backward compatibility with WGET1, which is just port the switches that aren't available on WGET2 yet, which now, if we don't count the FTP switches and the web archive switches, they are just little, not very much. We have issues open about those switches that aren't implemented on GitLab, so anyone comes just get one. It's you can look on WGET1 to find the exactly behavior it has to have, and then you can send a patch if you want. Well, we don't have now web archive format support, which WGET1 has. Darcy is working on a libwork library, so we may use it to get this work in the future. Well, we don't have quick protocol support, and of course not HTTP3. I also mentioned, already mentioned expect-CT, which is the replacement for HPKP, and we are hoping we can add it soon. We are already working on asynchronous DNS resolving support, which is just we are going to run another thread on WGET2, which when you provide huge or a big list of URLs, it starts getting all the DNS information on the background. So we avoid the bottleneck of having to get the DNS, the IP of the server just when we are going to download it, as we can already got all that information on the background while other files were downloading. That's the idea. We are going to use CRF. It's the one who uses. Also, we would like to enhance documentation, which is, well, documentation, yeah. And, well, now I'm going to show something.
There's a guy called Igor Kubin, and he, on the curl up, this is a curl meeting, I was in May. Yeah, he told me he wrote some special ASCII stuff for curl, and he was very happy to see WGET2 because of its multi-threaded and asynchronous behavior. So he could build something, I hope it will work, that yeah, I showed to in already. So what we have here is a small, command line. So we generate keystrokes, pipe them to WGET2, and create automatically requests. And what happens, crossing fingers, because Igor contacted me half an hour ago and said, oh, it should run now. But okay, wait a minute. Wow. Well, as we see, we don't see anything. Ah, now it's starting, right? You see that? I can. Well, I'm pretty bad at Tetris, and now the internet connection hangs, but in theory, with a functioning internet connection, we would see, yeah, well, every second would be see an advancement here. We could play Tetris. It's on the server, and we could just play it with a small command line. Sorry that it doesn't work. Oh, here.
This will present as an Ethernet interface if you're lucky.
Ah, okay. Wait, look.
So
It's
oh, no,
now it's going. Okay. Oops. Something like this. Without installing Tetris, you can just play it on the console without installing it. That's a point. Again? Yes, and this is what we see here is the output of our request. This is the response. We display it on the screen, and yeah, that's fancy stuff. You cannot do it with WGET1 because the command line minus input file standard in doesn't really work asynchronously. Well, it also doesn't work with curl, by the way. Yes, right.
What are you transmitting? I mean, who is painting? Are you
Yeah.
transmitting pixels, bitmaps, or you are transmitting pieces, movement?
No, it's just ASCII. It's coming with ASCII, right?
100 escape sequences to do this.
Yeah. Yes, really. That's a fun part, and it's just a little bit of bash magic here to read the keys and to generate.
And then when you read a key, you do a pause.
Yes, right. It's pushed every time you read a key, or if you don't press anything, it pushes once per second. So you see it coming down, once per second a request.
And instead of Tetris, would you run,
Well,
let's say, Emacs, for example, or some applications using...
in theory,
Is
yes,
that your goal?
but you need it, but you need it on you need it on the server, right?
What type of website is it that you can take pictures?
Yeah, this is specially designed for WGET2.
Okay.
He tried this with with curl, and this is the guy. Right, like that. Wait a minute. Doesn't we have the wetter stuff somewhere here? No. Just what was it?
Just WTTR.in.
Okay, wait a minute.
Minus O minus.
Reddit this one? Why is the cursor gone? Wait a minute. Oh, okay, that's better. Almost better. No. Was it all? No. Minus Q for quiet, and O minus output to the standard out. And well, that was the weather stuff that we already saw a while ago. Wow, the connection is all the servers. With this trick, well, it doesn't work now. Do we have connection? Well, I don't know. Okay, maybe we have to wait. He's doing this weather page, so through geolocation, well, you can add a slash your town, for example, and a lot of other stuff, and he generates, here's the graphics for the current weather now. Wait a minute. Yeah, wait a minute. Wait, a little bit. Wow, okay. Should we do it again? Yeah, maybe. I hope it's faster. But you get the idea. The terminal wasn't wide enough. But he said Madrid, Spain. So geolocation does work, and he gives you the current weather and for the day and for the next days. And this, well, you can just make an alias like weather or whatever you like, and have the current weather simply on the console for people who are console workers.
For people who can't be bothered to look out the window.
Yeah, for example. Well, okay, here we have it. Madrid. Or if I want to see that, Hamburg. Oops. Oh. It looks like that the servers are a bit slow currently. He has, I don't know, I forgot. In May he had like 1 million calls on his server per day. Something like this. It's pretty crazy. People are using it like hell. You know? Yeah, Hamburg. Light rain shower. That would be nice, right? Ooh. What, 12 degrees? Ooh. Okay.
One last announcement I'd like to make about the features in WGET2 is there was a major feature request that during last GHM said we want first-class support for checking signatures when downloading a file. Yeah. We in fact had this ready for GHM 2018. We just didn't manage to organize one. But if you download a file with WGET2 and it will send a request to the server checking if a GPT signature also exists. If it does, it will download it and verify against it. If you have the signature, it will also verify against the web of trust. So if you've already signed the signature locally, the key locally.
Yeah, that's good.
So yeah, you can like just use WGET2, download a GNU package, and get it verified. It's transparent for GNU packages, but not for, say, the kernel binaries, because they use a different way of signing than how GNU does it. But yeah, we have something in mind for doing this on a per URL basis and just organizing it more transparently for you. Cool.
I have two completely different awkward questions. I'll do the easy one. The thing that most annoys me about WGET is that there is no sensible option of set of command line options to produce normal Unix command line behavior, which is that if the program succeeds, it writes only to its intended output files, including maybe studout. And if the program fails, it will exit non-zero and print a message to stder, and then it won't print messages to stder on success. This is like what you would expect from a normal Unix program. It's very hard to get WGET to do it. I think curl can more or less manage it. I don't think you can fix this and be compatible with WGET1's command line interface. So what is your opinion about all that?
I know of this. Okay. Yeah, I know about this critique, and I completely agree with you with WGET1. That's been kind of annoying in general, and it's one of the chief reasons we say that while we want WGET2 to be a drop-in replacement for WGET1, there are some design decisions we really want to change. The semantics of -O for output file being one of them,
and where we output things by default being another. So yes, that's something I have in mind.
Excellent, thank you. I'm very happy to hear that. Now, for my second, even more difficult question. So you mentioned multi-threading. When any time anybody tells me they've rewritten some program to be multi-threaded, I get the screaming heebie-jeebies. What methods are you using to make sure that you don't have any threading bugs in your program?
Well, it's never a bug. If it fails, it's still a feature. but no, on a more serious note, yes, it's quite difficult to do that, right? We do try to regularly run it over Valgrind, hope that we catch something. We run it with GCC and Clang's address sanitizer, thread sanitizers, which make checks at runtime, but they also make these heuristic checks on it could have caused a issue because you didn't have your critical sections correctly done. So we try doing all of that. You can't be guaranteed.
Yeah, we can't guarantee. We have made certain design decisions like we do not use global variables. Every thread has its own space of variables. The only central connection point is, well, it's a shared queue if you want. And threads, workers, have to get jobs out of the job queue. So in easy words. And here we have indeed some database that we have to lock against each other. So we use mutexes, of course. And well, if we have a bug, I'm pretty sure we would see it pretty soon. Well, we can just reduce the code that is really, well, call it a critical section, as small as possible. That's what we do.
The question was, is the mutex a global variable? Yes, obviously, but that's not. Thank you. That is a really good answer to my question.
What threading library do you use?
We use Glue that covers certain kinds of threading libraries depending on the operating system. Windows threading, P-threads, and well, some other, I don't know. So everything that GNU-lib supports. Currently, I just got support for C11 threading. So that will come soon into WGET2 as well.
Is that the new pthreads module from Bruno?
Yeah.
How does it work? Does it work good?
No, yeah, okay. We didn't test it out yet, but it will come soon.
I think it's awesome to have a portable pthreads implementation.
Yeah, that's pretty cool, right? Mm-hmm. We will use it definitely.
One last question, which I think is very easy. Well, I hope will be very easy to answer. WGET2, it sounds as if is a complete new re-implementation. It uses little or no code from WGET1. Why call it WGET? Why not something else?
Yeah, we started with a different name, or I started with a different name. And but was very also very active on WGET. So well, after some kind of discussion and some featureness, we decided together to call it W2 because we want to just give people new technology. Why not? Yeah, good question. Why did we call it WGET2? Because to tell you that there's a new version, a modern version, but you still can rely on it and has the same features and
plus much, much more.
Yeah. Micro's coming.
So if I can just extend on that part a little bit, it's kind of a two-part answer. One, why is it still WGET and not something completely different? Since, like you said, it's its own code base. But we intend, which is why. So that's the first part I want to get to, is that we intend to have as much as possible of backward compatibility of all switches with WGET. So WGET2 is intended to be for most intents and purposes, a drop-in replacement for the original WGET. So, which is why it makes sense to continue the name. We have, a lot of the decisions have come from learning from the mistakes of WGET1 itself. The people writing it are the ones who used to maintain and still maintain WGET1. Why is it 2? Is mostly because we need a major version bump to declare that there are backward incompatibilities, something that we've been very particular about not breaking with WGET1 in general. So that's why it's WGET2.
So you can have all the merchandising already.
Well, he's wearing the T-shirt.
Just to add something, what you said, Dashit, is WGET2, it's easy to implement it in parallel with WGET. So you can easily install both, test your scripts, whatever you have with WGET, and then decide, okay, in the future I use WGET2. And that was the point. Else you have a hard break, and this is always bad.
Anybody else? Or
I've made some WGET stickers. So,
but WGET1 or 2?
They are like well, well, more or less. Well, it's like that. It has the GNU Hackers Meeting there, so it's also a gift from GNU Hackers Meeting in Madrid.